I'm going to show a couple examples that require L'Hopital's rule, and the interesting thing about these limits is that they don't directly fit the definition of L'Hopital's rule. You have to do some clever manipulation to get them in that form. So the first one here is the limit as x approaches, and this is a mistake, it should say x approaches 0 of x to the x power. And if you think about it, that would be a 0 to the 0th power, which is indeterminate. We don't know how to do that exactly, and L'Hopital's rule doesn't address this cleanly. So what we're going to do is we're going to let y be this x to the x value, and then I know if I take the ln of both sides, I can use properties of logarithms to pull out that exponent. This is x ln x. So then my question now becomes, let's take the limit as x approaches 0 of ln y. And so that's the limit as x approaches 0 of this x ln x, which does not satisfy L'Hopital's rule either, because as I approach 0, I get 0 times negative infinity. If you recall, the graph of ln is something like this. You have a vertical asymptote at 0, at x equals 0. So this is not L'Hopital's rule either, except if I do this. If I say ln x, instead of saying x, let's say 1 over x. Dividing by a fraction, same as multiplying the reciprocal, so this works. And in doing so, I now have negative infinity over infinity. If you remember the graph of 1 over x, as I approach 0, I'm going up to infinity. So I can use L'Hopital's rule on here. So I'll take the derivative of both sides, or the top and the bottom. The derivative of the top is 1 over x. The derivative of the denominator is 1 over x squared. And so now applying the principle that dividing by a fraction is the same as multiplying the reciprocal, I get negative x squared over x, which is just the limit as x approaches 0 of negative x over 1, which is just 0. Now recall though that this is the limit as x approaches 0 of ln y. We get 0. And we didn't want that. We want the limit as x approaches y. We want the limit as x approaches 0 of x over x, which is the limit, or x to the x, which is the limit as x approaches 0 of y. And so the way I get from ln y to y is I exponentiate. So I'm going to exponentiate this value. I get e to the 0. And so there's my answer, 1. So the limit as x approaches x, as x approaches 0 of x to the x power is 1. Alright, now we're going to repeat this process with another example that I think is pretty interesting. And here I want the limit as x approaches 0 of x to the power x to the n. And here I should specify that n is greater than or equal to 1. So if I do this, again, I'm going to get a 0 to the 0 power. And so I'm going to apply the same technique. I'm going to let y equal x to the n power. So then ln y, through properties of logarithms, is x to the n ln x. Okay, so then if I take the limit as x approaches 0 of x to the n ln x, we know, just like last time, that this is still an indeterminate form of 0 times negative infinity. And so I'm going to rewrite this then as x approaches 0 ln x over, instead of saying 1 over x to the n, I'm going to say x to the negative n power. And now this is a negative infinity over infinity, because 1 over x to the n power graphs like this. And so as I get close to 0, I go up to infinity. Alright, so now this will allow me to use L'Hopital's rule. So when I take the derivative of the top, I get 1 over x. When I take the derivative of the denominator, I get negative n, subtract the power by 1, so that's negative n minus 1. And remember here, the x to the negative n minus 1 is the same as 1 over x to the n plus 1 power. Okay, those are the same thing. So now when I evaluate this, does this satisfy L'Hopital's rule? Well, yes. And so here I can simplify my algebra to get negative 1 over n. bring that x to the n plus 1 in the top, divided by x. And so I get negative 1 over n. I need to cancel out 1 power of x, so I get x to the n, which goes to 0. Now just like last time, recall, this is the limit as x approaches 0 of ln y, we get 0. But we wanted y. So to get back to y, I have to exponentiate this value here. So I get e to the 0, which is 1. So there it is. So for any value of n greater than or equal to 1, this limit will be 1. Okay, I hope this is helpful in showing how you can use L'Hopital's rule to evaluate limits that are not always straightforward. If you have any questions, please let me know in the comments. I'll be glad to help. And thanks for watching.